AI answers can feel instant, almost magical, but behind that loading screen is massive data scraping. Models are trained by pulling content from millions of websites, often without permission. At scale, that traffic can crash small sites, drain creators' audiences, and shift value away from the people who made the content in the first place. We already have names for unfair copying, plagiarism, patchworking, and remixing without credit, to name a few. The problem is deciding where AI fits into all of this. If a model paraphrases thousands of sources at once, is that transformative or just plagiarism at scale? And who gets to decide when something is new enough to be legal? Copyright doesn't protect ideas, it protects expression. That means specific wording, images, characters, and creative choices. You can write about the same topic as someone else, but you can't reuse how they expressed it. AI challenges this because it learns directly from protected expression. Fair use, on the other hand, is the main legal escape hatch, but it's not one simple rule. Courts weigh four factors, including whether the use is transformative and whether it harms the original market. With AI, those questions get messy, especially when outputs compete directly with the sources they were trained on. When rules are unclear, courts draw the lines, and those lines shift over time. That's why similar AI cases can lead to different outcomes. The technology moves faster than the law, so judges end up defining what's acceptable case by case after the harm has already happened.
Better understand this issue, we need to know how a large language model actually works. Whenever a user types a prompt, the model chops the prompt up into smaller units called tokens. From there, using training data, it then attempts to predict what token should come next. The issue lies in this pattern prediction, since overexposure to specific data makes certain phrases much likely to be predicted and returned, sometimes completely verbatim. This process, alongside the data it requires and stores, are housed in massive computer and storage systems. Training models this large requires an absurd amount of training material and storage, so companies are incentivized to ingest data at breakneck speeds and at massive scales using web scraping. With this much data, small choices about data sources and how to actually source it turns into huge legal and ethical risks. If there's this absurd scale of data, then it can be incredibly difficult to prove where it all came from. What permissions apply for every source, how the data is being used, how certain data is weighted, and so on. Without knowledge of these things and the origin of certain data, it's impossible to prove if companies have the right to actually use that data. Moving forward, governance is only going to be a bigger issue.
To understand the legal and ethical concerns of modern AI, we first have to look at where the data comes from. Vast repositories of human knowledge, such as the Internet Archive, have been scraped to train these massive models, often completely blurring the lines of fair use. Millions of books, articles, and private texts are ingested without the explicit consent of their authors or copyright holders. From an ethical standpoint, this raises a massive red flag. Creators are entirely left out of the financial loop, while tech companies profit of their original, underlying work. But how do we know the models aren't just learning concepts? Research shows that we can execute a training data extraction attack on models like GPT-2 by feeding the model specific prefixes. We can force it to generate text, evaluate the output, and run an internet search to check for memorization. Often, it's an exact match. This exact memorization is where the ethical issues turn into severe legal and financial liabilities. The New York Times, for example, discovered that AI models were reproducing their payword, high-quality journalism almost word for word, bypassing the need for users to actually visit their site. This culminated in a landmark lawsuit, the New York Times versus OpenAI. It highlights the core of the financial and legal debate today. How do we protect intellectual property, enforce copyright law, and ensure creators are compensated when their data becomes the engine for billion-dollar algorithms?
In the lawsuit, the New York Times says that generative AI tools don't just learn from journalism, they can repeat it. And if the answers look like the article, people will stop clicking or subscribing to news as a whole. The harm that they're pointing out is simple: AI becomes a free substitute for news companies. Meanwhile, OpenAI says training is transformative. The model isn't saving articles, it learns patterns so it can answer new questions. They also argue most outputs aren't verbatim and guardrails can reduce copying. The key question becomes: does generative AI transform information, or is it a system that recreates copyrighted text? This case depends on where the similar text comes from. It can come from memorization during training, from prompts that push the model to repeat certain articles, or from web retrieval that pulls text and just summarizes it very badly. No matter what, if the system of large language models act like a copy machine, the legal risk goes way up. Ethically, this lawsuit is about consent, credit, and payment. If journalism trains models, who eventually benefits? A practical middle ground is licensing and guardrails that block long, near verbatim outputs. The end goal is supporting both technological innovation while balancing the ability to fund real news journalism. This isn't just one lawsuit, it's a test case that will shape the rules for AI and the internet. If the decision favors unrestricted use, journalism will lose revenue while AI continues to copy journalism. If it's too restrictive, AI development slows and access shrinks. Either way, the precedent will outlive this moment. So the real hope should be a rulebook that protects original reporting and allows useful AI to continue training and becoming smarter and more useful to humans as a whole. And here are the citations for our presentation and executive summary.